Hello everyone, it's 1 p.m. Eastern and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thank you for joining us today. I'm your host Henry Regis, and running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. You know, it always seems like when I'm on this broadcast that it's sunny. We have a lot of sunny days out here in Colorado. For those of you who are unable to attend us or attend the live broadcast today, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from the National Science Foundation and donations from listeners like you. Well, today we're going to talk about the COMET program, and these are freely available online lessons in weather and natural sciences. Yes, you did hear me correctly. I did say free. Many of our CoCoRaHS observers have asked for additional resources to learn about these very subjects, and our guests will be telling you about the over 800 hours of online lessons. Those are in meteorology, hydrology, climate science, oceanography, and astronomy that are freely available. And speaking of guests, we have two good friends of ours from right down the road in Boulder with us today, and they're good friends of the CoCoRaHS network. This is Greg Bird. He's the Deputy Director and Manager of Business Development and Outreach of COMET. His degrees include those from Penn State, Colorado State, and the University of Oklahoma. Before arriving at COMET, Greg was an Associate Professor of Meteorology at the State University of New York College at Brockport. And Greg has been a CoCoRaHS observer since way back in 2001. Sharing the microphone with Greg is our other good friend and Boulder County CoCoRaHS Coordinator Matt Kelsch. Many of you know Matt. Matt is a hydrometeorologist with degrees from the State University of New York College at Oswego and the University of Oklahoma. Matt has been an active weather observer and gardener since he was 6 years old. Matt grew up on Long Island, New York, just a few miles from my house at the time, and we always talk about that and have that in common. And by the way, you can listen to Matt's CoCoRaHS Weather Talk webinar on flash floods. That was back from April of 2012. Go to our archive and choose webinar number 5, and you'll find that really interesting. Well, welcome, gentlemen. It's really great to have you with us today. And I think they're out there. There we go.
We're here. I'm getting the speed up.
Terrific. Did you guys have any frost down your way today?
We did.
Yeah, I think my tomatoes have bit the dust for the season now.
I think so. Okay, I'm going to pass the headset over to Greg right now, and then I'll be back later. This is Matt.
Okay, take it away, guys.
All right, headset is deployed here. Can you hear me?
You sound good, Greg.
Oh, thank you. So should I just go ahead and get started here?
It's all yours.
All right. Well, welcome everyone. We're delighted to have the opportunity to talk a little bit today about the COMET program. I am Dr. Greg Bird, Deputy Director of the COMET program, and of course Matt Kelsch is here as well. I'm going to just walk through a brief overview of what our program is all about and then turn it over to Matt for the fun stuff. He's going to walk you through a few things that are probably more relevant materials that we have for the CoCoRaHS community. Of course, setting the stage for this, why do we have education and training? Well, part of it is how can we be better prepared to do things and react to weather and work in the weather community. This is an example from 6 or 7 years ago where there was a stage collapse at the Indiana State Fair. There was a concert going on. This was as a result of high winds with a convective system of thunderstorms that was moving through. And unfortunately 7 people died from this, largely attributable to not really being proactive in trying to take precautions for a severe weather event. And of course, an example of good training is there's a movie out, Sully. It's Captain Sullenberger from the U.S. Air Flight 1549, which successfully landed in the Hudson after engine problems, and nobody was hurt on that flight. And a lot of that is attributable to good training. Training is about getting people ready to execute and put their training to the test when the organization needs it most. So, about the COMET program. The ET in COMET is education and training, and we were created in 1990 primarily to support the modernization of the National Weather Service. Doppler radars were deployed back then, new analysis and display systems, and we were charged with trying to get the latest scientific research results to the forecast desk so that it could help improve forecasts. We've been in business over 25 years now, world-class education and training. We started out in the Laserdisc era with distance learning, and then proceeded to CDs, and then finally in the late 90s to the World Wide Web. And our website, the URL is actually up there. You can see it, the MedEd website, meded.ucar.edu, is a free and open site. And some of you are probably already registered users, but you should take advantage of this. And if you are interested in what you see today, I certainly encourage you to become a MedEd user. We're an award-winning program. A number of awards that we've received over the years. I'll just highlight two of them. In the upper part there, there's a Brandon Hall Excellence in Learning Award that we received back in 2004. That's a corporate training award. We're a $5 million program, and we won a gold medal. A silver medal was won by American Express, which has a $280 million budget for training. So we were in pretty good company there. The other one is the national, or is right beneath that, is the American Geophysical Union Excellence in Geophysical Education Award. It's only been given to two groups. It's usually given to an individual. And the other group was the Museum of Natural History, so we're in pretty good company there as well. Some of our details of our program: we are agency sponsored primarily, federal agencies and international agencies. They include NOAA, the satellite service NESDIS, the National Weather Service, the National Ocean Service. Domestically, we are also involved with the Bureau of Reclamation and the U.S. Navy. And internationally, our sponsors include Meteorological Service of Canada, the European Satellite Service, EUMETSAT, the Bureau of Meteorology in Australia, and several other entities as well. We have a staff of 25 subject matter experts, scientific experts in meteorology and hydrology, and we even have an engineer on staff. Instructional designers, they are really the bread and butter here. They make our material highly interactive and engaging for the learner. And of course, we have the web and application developers, graphic artists. We even have a strict Spanish translator on staff, and our IT staff and administrative support. The MedEd website now, it is probably the premier geosciences education and training website in the world. There are close to 400 English language modules, and about a third of those are in Spanish, and about 60 of them in French. We have over 800 hours of self-directed distance learning material. This is really the cornerstone of our program, is this MedEd website. And as I said, it's a free and open resource, so you can become a registered user. It's very simple. You can do it with your email and create a password. We're 450,000 registered users, growing at about 5,000 a month. About a third are international, and a third are students representing over 1,500 universities in the United States and many other universities internationally. Another interesting statistic is about 52,000 return users each year complete 3 to 4 hours of instruction. Just to give you an idea of the distribution of users in our database here, primarily education users, over 40%, and a lot of those are .edus, the university community, but also K through 12. U.S. agencies, which are our primary funding source, is about a quarter, and then another area to highlight is weather enthusiasts, which most of you are out there. That says 7%, but that category was only created about 2 or 3 years ago. We suspect that a lot of the other or not identified 20% also comprise that list. So it's probably safe to say that at least 20% of our registered users are weather enthusiasts, such as you. Our long-term success is involved with partnerships of science and instruction. We work in close partnership with our constituents and our sponsors. There's a focus on quality, but we always balance that with efficiency so that we're very cost effective. And we also like to stay on the cutting edge, so we're very flexible and adapt to new technologies as they come along. Our sweet spot is the intersection between the development of geoscience content, instructional design and media services, and web applications and technology services, and underpinned by our business office, our business development efforts, and the workforce, the capabilities of our workforce. COMET's niche is distance learning, and there's a wide variety of web-based distance learning offerings, including recorded lectures, lessons that are self-directed, and courses, and facilitated courses and webinars, as well as learning and media object resources. COMET services include facilitating virtual and residence courses. We have about 10 weeks of those a year, but that demand signal is growing. Virtual courses include topics such as climate variability, hydrologic impacts under climate change, which Matt has been very involved in. Residence courses, winter weather and mountain weather, are two examples. We actually recently did a course for the Korean Meteorological Agency training their Olympic forecasters, the Olympics coming up in 2018 winter. So we talked a little bit about winter and mountain weather with them in preparation for that event. Facilitating meetings and workshops, we do that as well. Our instructional and media design services include developing training needs analysis and identifying gaps in training, and how you can make your workforce or yourself better and stronger at being able to do your job. Video scripting and production, we do a lot of that. Media development as well. We have a multimedia database with over 40,000 animations and graphics contained within it. One other area that we have just started moving into is an area called capacity development. And capacity development involves improving services and products to the end users. Too often back in the day, weather forecasting was a scientific problem to be solved, and now it's more of a, yes, it's a scientific problem to be solved, but we have to be knowledgeable about the impact on the end user and provide support to decision makers that allows them to use the forecasts in a proper way and in the best way to help the end user. And one example of that is weather-ready nations. That concept started in the United States with the idea that we would all be collectively become a weather-ready nation. That has been extended through the World Meteorological Organization internationally now, and we are very involved in that effort here at COMET. I believe that does it for my section here. I will go ahead and turn it over to Matt now.
All right, thanks, Greg. So I'm going to talk weather and where CoCoRaHS and COMET intersect. I'm a weather observer myself. CoCoRaHS coordinator for Boulder and Broomfield County in Colorado, and I also maintain 3 CoCoRaHS stations within the city of Boulder. So I'm real busy on snowy mornings, as those of you that observe snow and melt it down, that that could take some time. And I'm a National Weather Service Cooperative Climate Observer, and I've also been recording daily weather records since I was 10 years old in my native Long Island, New York. This is me at the Cooperative Observing Station in Boulder, a 26-inch snowstorm back in December of 2006. And I did all the CoCoRaHS, the other 2 stations I have for CoCoRaHS in that storm too, so real busy morning. More recently, in 2013, some of you that are from the area know this, maybe you remember from the news, major rain event along the Front Range and historic flooding. And CoCoRaHS really provided useful information, very detailed information on where that rain fell. This is one of the creeks in Boulder that was flooding, and I took a picture of it after the flood to show you this is a bicycle path, what it looks like when the creek is not up and over its banks. And the rainfall information that we got out of CoCoRaHS, all these numbers you see here, they're not all CoCoRaHS, but most of them are. These are the counties of the northern Front Range of Colorado. This is Boulder County right here. Boulder, on one of the several days where this storm occurred, had 9.08 inches of rain, which was an all-time record for the city, and that is me actually measuring it. That's not staged, that record rainfall. 2 of the stations I have, I use the regular plastic CoCoRaHS gauges that you're familiar with, 4-inch diameter. At the climate station, you'll notice this is more of a metallic gauge. It's also a slightly larger diameter, 8-inch. But it's the same idea with the inner funnel and the outer funnel to capture the rain. And that was right there where I was measuring the rain. Those white areas were more than 15 inches of rain that fell over several days. So what I want to talk about is what COMET might be able to provide you as CoCoRaHS observers and weather enthusiasts, but also I'm going to get into what CoCoRaHS provides both the university community, many of our users are university folks, and the research community, as well as other weather enthusiasts. One of our module, we have a lesson on rain gauge. It's getting kind of old now, but there's still a lot of useful information in there from 2001. Some of you know Nolan Duskin. This is Nolan 15 years ago holding a CoCoRaHS gauge when the network was still fairly new. In fact, back then CoCoRaHS stood for Colorado Collaborative Rain, Hail, and Snow Observing Network because it was only in the few counties in Colorado at the time before it expanded. And Nolan was presenting to a National Weather Service class. Many of them had never heard of CoCoRaHS at the time, and that's certainly not the case today. In 2009, we published, this is a somewhat more technical lesson, but it's a lesson on precipitation measurement, whether it's from rain gauges or radar or satellite. But there is a section on there specifically on rain gauge that you might find useful, and I'll show you a few graphics from that lesson. One, we're pointing out the utility of rain gauges. Each of these kind of cylinder-looking shapes you see on the bottom represent a rain gauge, and most of you know if you've been doing this for a while, especially in the summer when precipitation is showery. A lot of times it goes in between the rain gauge sites, and you're not the one that gets the big rain amount. This is where radar comes in, seeing rain more continuously, but radar is an estimate of rain. It's not directly measuring the water like rain gauges are. So rain gauges are very good at helping us calibrate radar and satellite estimates of rainfall. And then radar helps fill in the gaps in between the rain gauges. So together, these are a multi-sensor approach to measuring rainfall and snowfall accurately, and rain gauges are, of course, an extremely important part to that. Now, the problem with gauges, as we go through in the lesson, there are several things that can reduce the accuracy of a rain gauge report. Wind is one of the big enemies. And in this particular photograph, you can kind of see the angle that the rain is coming down with. Rain rarely falls straight down. Sometimes it does, but it rarely does. And what we see around a gauge when it's windy is for a 2 millimeter diameter drop, which is 1/10 of an inch. That's a typical raindrop diameter. I should point out raindrops aren't teardrop shaped like you see in cartoons, and they're not spherical either. They tend to be shaped like hamburger buns because of the air resistance as they fall. But when the wind is blowing, you get a little bit of an increase over the top of obstacles like rain gauges, and then you might get a kind of a deflection downward because that obstacle will disrupt airflow and cause a little turbulence. This deflection downward is something we want. It helps improve rain gauge catch. So what you see, not at CoCoRaHS sites, but other climate stations, is we put what we call wind screens around the rain gauge to help disrupt the airflow and kind of turn the trajectories of the drops more downward. And this photo is an example of what these wind screens might look like for some of the automated rain gauges. Again, the wind blowing across here gets a little bit disrupted, and so the trajectories of drops coming down at an angle is to turn more straight downward toward the gauge. Now, CoCoRaHS is an example of a manual gauge, which definitely has its advantages. Someone is going to the gauge every day and actually physically measuring the water or the snow that is in the gauge. The disadvantage is you don't get 5-minute reports, hourly reports, and that's where automated gauges, like this one we call a tipping bucket gauge, comes in. And this is a cylinder, but in this graphic we cut away the outer shell so you can see the inner workings. Basically the rain falls in, and for each 100th of an inch this little teeter-totter type apparatus ticks back and forth. In our lesson it actually is animated. I didn't bother to do that in this particular presentation. So you see a lot of these automated gauges at different weather stations as well. But whether you're using a CoCoRaHS gauge that's manual or a tipping bucket gauge, they're all subject to the problems from wind. And this graph shows the blue line is on average for a 1/10 inch raindrop. Again, that's about the average size raindrop. If you're getting a wind of 20 miles per hour, the numbers in parentheses are miles per hour, you're losing about 20% of the rain. Now this decrease, or this undercatch because of the wind, is less when you have big drops like in thunderstorms, but it's more, the error could be even greater when you have drizzle drops, which are those really tiny drops that feel like mist when they hit your face. Those really move along quite nicely in the wind and often are just hitting the side of the gauge. This problem grows when you have snow. As you can imagine, snow gets moved by the wind more than raindrops do. So in this graphic, I'm showing the numbers on the bottom here are in meters per second. I'm assuming most of you are more familiar with miles per hour, so I put that in blue. And what this is showing is what the snow really is that fell compared to what the gauge is catching. So even at 10 miles per hour, in many instances, only about 50% of the snow is actually going into the gauge. And I took a picture of one of the CoCoRaHS gauges that I maintain here in Boulder, and you can see what's happening. It's accumulating on the side. So there is undercatch in these gauges during snow. Some of you do the core measurements where you actually take your rain gauge and put it upside down on the snowboard and get a core measurement, which helps improve the accuracy. Also, if your gauge is close to the ground, wind tends to be a little bit lighter as you get closer to the ground. There's more turbulence and stuff, so that improves the catch over a very highly exposed gauge that's blowing in the wind. And automated gauges, see CoCoRaHS gauges, even with that problem, they can still be much better in snowfall than automated gauges, because what the automated ones do, in order to measure the liquid, they melt the snow, so they're heated. So you can imagine as the snow comes in, it melts and it goes down into that little tipping bucket to measure the liquid. But because it's heated, and especially if it's very cold outside and you have those real fluffy snowflakes, a lot of times these gauges evaporate the snow without ever measuring the liquid. So you get, in addition to the wind, you get an undercatch because of evaporation. Or if it's snowing real hard, it's not melting the snow fast enough and you just get overflow and lose the snow that way. So CoCoRaHS is very important. I'm going to move in now to how researchers use the information. This map is showing what we call snow to liquid ratios. And you might be familiar with this. Maybe when you were younger, you were told there's 10 inches of snow for every inch of rain or every inch of water. And that's a rule of thumb that's been used not only in the United States and Canada. The interesting thing is that's a rule of thumb that is somewhat inaccurate in most locations. And what this map shows, you might not be able to see the numbers, but these blues and dark greens are pretty much where you have a 10-to-1 ratio. An inch of liquid will give you about an inch of snow. Now that, of course, varies from storm to storm, but this is over 30 years for the whole winter season. That 10-to-1 ratio is a little bit more representative when you get on the west slopes of the Sierras and the Cascades, down across the south and up the east coast. but the average in the United States is actually closer to 13 to 1, 13 inches of snow to every inch of liquid, and that's these lighter greens and yellows that you see through much of the Midwest and the eastern slopes of the Sierras and the Cascades. And then around the Great Lakes and in the Rocky Mountain region, some of the high plains, that's where on average we're seeing snow ratios that are getting up over 15 inches for every inch of liquid. And we derive this information from rain gauge reports where people carefully measure the snow and measure the liquid that's in it. And so we thank you for all the work you do. I know it's sometimes not easy going out on a cold morning and getting those reports. This is a very busy graphic, so let me tell you the stuff I want you to pay attention to. Since I'm assuming you're more familiar with Fahrenheit than Celsius, just pay attention to the bottom here where we go from 32 and it gets colder and colder to it's minus 30 Fahrenheit. You don't have to worry about these numbers specifically going up the y-axis. Just keep in mind it gets more moist as you go up. So what I'm showing here is snowflakes and snow crystals are different depending on the temperature and moisture. And when you measure snow and liquid in CoCoRaHS, that tells us a lot about the character of the flakes that fell, and it's really important for research. For instance, when it's very close to freezing, and this is probably no surprise, we're closer to that 10 to 1 ratio because there's a lot of water in the snow. Sometimes it's even snowing when it's above freezing, and you can have even more dense snow than 10 to 1, something like 6 to 1 or 7 to 1. As it gets colder, we get a crystal type that we call columns. This is when the temperatures are like in the 20s where the snow is forming. And in some cases, the columns are really long and narrow. We call those needles because the shape of them. These are drier, but they tend to accumulate fairly densely because there's not a lot of airspace. The sweet spot for people that really love snow or skiers and so forth is when we get in temperatures between about -5 and 15 degrees. That's where we start getting a lot more of the dendrites. These are those really pretty snowflakes that have these arms of crystals that reach out, and when they accumulate, there's a lot of airspace, so they could be really fluffy, sometimes all the way up to 50 to 1. Now, as it gets bitterly cold, the snow crystals tend to go back to more columns and very small plates, so it's dry, powdery snow, but it tends to be a little denser again in extremely cold conditions. And again, the CoCoRaHS reports really help us understand what's going on in the clouds because we could, by knowing what the snow ratio is, we have a sense of what the moisture and temperature profile is in the clouds. These are just some photographs. These are needles. I was talking about the needles, how they kind of stick together and accumulate. And this is one of dendrites. See those real pretty branches that come out, and these are several dendrites stuck together in a big snowflake. And then at other times, there's liquid water in the cloud that's actually below freezing, and it'll stick to the snow crystals, so you really can't identify what they are, but they're just these big kind of globs of icy snow. And outside, these are kind of like those, we call them snow pellets. They can even bounce when they hit the ground, and they tend to be fairly dense. Again, I was mentioning the snow liquid in the clouds. Sometimes it's little teeny tiny droplets. So here you see a nice pristine snow crystal. Here's one that's picking up those little tiny droplets, and then here's one that picked up a lot of liquid water droplets that just froze to the snowflake. So this is a very dense flake. And what's happening to the crystals also happens to airplanes as they fly through the cloud, which is why it's real important why we in the science community study the properties of clouds and how snow and supercooled liquid water develop, and your reports certainly help with that research. Switching gears a little bit, some of you may have heard of the term atmospheric river, especially if you live on the West Coast. Sometimes it's called the Pineapple Express. What this is shown here is an area of high moisture. You're seeing these yellows and greens reaching down from around Hawaii. There's Hawaii right there to the West Coast. There you can see the West Coast. This was just last week. Atmospheric rivers, by the way, happen in the Gulf Coast and the Atlantic Coast too, but there's been a lot of studies on the West Coast now, how these form. And part of the study and the atmospheric river portal, which shows us a lot of information, like how much rain fell. This, again, was just last week, where over a foot of rain fell in these red areas you see in Washington, Oregon, and even into Northern California. There was even some places that had 7 inches of rain in a day. And how do we know that? Well, right on the atmospheric rivers portal, they give us CoCoRaHS reports. These are used directly by scientists studying these so they can understand water resources in the West Coast and mountain ranges and so forth. So these are the different reports that came in for one of the days last week where there was a lot of rain in Washington, Oregon, and California. Another recent storm that the rivers are still receding was Hurricane Matthew, which proved a fortunate near miss in terms of the intense winds for Florida, but it was not a near miss in terms of the intense rains that spread up the coast into North Carolina and Virginia. This is from October 9th, and these yellows and reds are precipitation amounts that are getting as high as 16 inches in one day. In fact, I'm going to zoom in on this county right here, Cumberland County. And on this day alone, there's reports over 14. Here's one close to 16 inches. And these are really important for scientists, including those at the Weather Service, to put together an accurate depiction of the rain that fell, which you see here. Some of these grays are over a 72-hour period. There's South Carolina, North Carolina, and Virginia. And the reason why it's important is this helps with river forecasting. This was the Lumber River in North Carolina from the rain that fell. The blue here is showing how the stage is in feet here, of the river increased. And this line right here at 13 feet is where the river reaches flood stage. This line right here is the all-time record, 18.3, and you can see last week after all that rain, they blew right past that record all the way up to almost 22-foot stage. And again, rainfall reports from both radar and the numerous rain gauges are important for these river forecasts. And then there's also snow. Earlier this year, big snowstorm on the urban corridor of the Northeast. And those yellows and reds there are showing on the order of 30 inches in just one day. This was a 2-day storm stretching from around Washington, D.C. up toward Boston. But there's a very sharp cutoff to the north. So really important detailed information. And as we study storms and university students do studies on these, we could try and figure out which storms are the ones that are going to be more widespread, which one have a more narrow focus to better support the emergency response community. And some storms are even more localized than this. Well, first I'll show a satellite here. Here you see the East Coast, the Outer Banks of North Carolina, up to the Delmarva Peninsula, Long Island, Cape Cod. And the white out here is clouds, but this white area is where the snow fell from out in the Ohio Valley, West Virginia, northern North Carolina, all the way up into the New York City area. Then there was a sharp cutoff. Go up to Albany or Manchester, New Hampshire, there was little or no snow that fell from that storm. Even more localized, I'm zooming in here on Erie County, New York, from November of 2014. These are one-day snow totals of 32, 22 inches. Next day, another 2 feet. This is lake effect, of course, Lake Erie right out here. In fact, I'll show you a map. There's Lake Erie. This is the county we were zoomed in on. Up to 60 inches of snow fell, but just a few miles away, it was just a few inches. In fact, downtown Buffalo didn't get the worst of it, but the southern suburbs did. Now, again, this is real important to understand these kinds of distributions of precipitation because of things like snow removal and emergency response when you have a blizzard like this. I'm going to get out of the presentation just momentarily because I want to show you just how localized this was. There was a really nice video of the lake effect. We're looking from downtown Buffalo, and this is the snow squalls that were coming off the lake. And there's a building right here that you see going in and out of the snow. It hits it, and so you can imagine, CoCoRaHS observer up in Buffalo might be disappointed they're not getting all that snow, or maybe they like that. But those that were just to the south really provided some very useful information of the nature of that particular storm. Oops. So if you want to go to our lessons, other stuff you can look at. We have stuff on severe weather, flooding. I've done a lot of the work on flooding, hurricanes, fire weather, winter storms. We go into oceans too, including tsunamis, and climate variability and climate change. So we do welcome you to look at the CoCoRaHS information as you desire. I think that's all we have. If you have any questions, there's my email, and Greg, who spoke before me, there's his email. And at this point, I will turn it back over to our hosts.
Thank you very much. Appreciate that, Matt and Greg. Great presentation. We really gave us a good idea of what's out there, and then how CoCoRaHS can play a factor in a lot of these lessons and things that we're learning. Folks, if you would like to type in a question for Matt or Greg at this time, go ahead, and then we'll read them off, and we've got a little bit of time left here this morning, so if you want to do that, we'll take them as they come in. And we'll just wait here a minute so we see if we get any coming in. And these are available. You can go to that website. A lot of different lessons on here. And there you go. So Eric writes in, he wants to know if you can comment on the Skywarn training available that's out there.
We do have spotter training based on the Skywarn, and if you go to the COMET MedEd website and choose convective weather, you will find, or you could actually, let me actually call up a website here and I'll show you. Just a second. Hold on. So the MedEd website, if you just type storm spotter or Skywarn in the search box, it will take you to, put Skywarn instead of Skywarn, but it knew what I meant. So there you have a link right to the Skywarn spotter training. So even with my typo, it still knew what I was looking for.
Excellent. We can put that on our website as well for you folks out there that would like to get that. Here's a question coming in, and this gentleman is looking to find out if the large 8-inch gauge, the metallic one, in the slides is available to buy somewhere. And I don't know if anybody that sells those. Are you guys familiar with that? They are quite expensive.
Yeah, I was going to say, I know they're a lot more money than the CoCoRaHS gauge. They tend to be used at the cooperative networks, which is why one of my 3 CoCoRaHS stations uses the 8-inch gauge. The nice thing about them is it could snow and rain a lot more without it overflowing. But they are bigger and they are expensive. I don't know. Maybe Nolan knows the answer to that, but I think they are like hundreds of dollars. I'm not sure.
Yeah, and you know that bigger gauge, you know, if you're elderly and so forth, that's a lot of water to try to tip into that funnel when you're emptying it. If you have 12, 18 inches of rain in there, it is a feat, and sometimes that can be pretty heavy for doing that. Back to the Skywarn, Eric was wondering if there's any issues with taking this training and having it accepted by Skywarn as valid training. Do you know anything about that?
You would have to check with your local weather service office. Aren't they usually the ones that provide the training? I think they are. And
I think that's where it goes, yeah.
Yeah, and
I guess they meant online, yeah.
Yeah, and this training was developed in collaboration with our weather service and NOAA partners.
Okay, here we go. Janice in Colorado wants to know, would you prefer to have velocities reported with rain and snowfall?
Oh, so you have, I'm assuming Janice must have an anemometer or something.
Right.
You could always put that in the comments when you report CoCoRaHS. I can't guarantee anyone's going to look at it, but you know, sometimes people, if they know someone's reporting that kind of information, they will look for that and see what the velocities are. So again, I'm assuming you must have a weather station that gives you that information. But it's good information. I just, you know, don't know who exactly is going to use it, but we certainly use it sometimes when we study the effects of wind on rain.
Here's Todd, and actually he's got a question that I can probably answer here. Wants to know if we can talk about the condition monitoring reports that we launched last week. And I don't know if you guys are familiar with those, but it's part of an effort with NIDIS and the CISA down in South Carolina, and also with the National Drought Mitigation Center. So instead of drought monitoring reports, we're now taking a look at the condition of your area. So just to touch on that briefly, there's a whole series of information on our website. If you go to the top banner, that'll take you through a training guide. Basically, we're looking at how conditions change at your location over time, and we're asking folks if they could report weekly. It kind of gives a good picture of whether it's wet or dry or pretty normal, and that does help a lot with our folks doing the drought monitoring. So that's to answer that question. Larry writes in from Kansas. He wants to know, are there any lessons regarding tornado activity in the central U.S. on the COMET list there?
We do. Let me bring we haven't done anything recently. But again, in the topics, I'm bringing up the med-ed here, we have a topic area, and one of the topics is convective weather. And there was a while back some severe weather stuff, but there was nothing specifically about tornadogenesis. But you might want to peruse through, like there's about buoyancy and cape, which certainly are, if you're familiar with those terms, they're certainly measures of how severe a storm could be and whether or not it will rotate. So there's stuff related to tornadogenesis, but we don't have any models specifically on tornadogenesis. We have stuff on squall lines and bow echoes. So you might want to take a look and see what we have and see if any of that makes your it suits your purposes here.
And you can look up a bunch of different things on there. Here's one from Randall, wants to know if there's a training for understanding Doppler images for radar.
Yes. Again, the same thing I just went to, the convective weather. There are some radar signatures of convective weather, and they'll talk about Doppler, like you see this one right here, radar signatures of severe convective weather. The one that has in hydrology, let me go to that one. So that was convective weather. We also have one called hydrology flooding. And I show you rain gauge information. Let me scroll down to that particular lesson. There's precipitation estimates. So this one, precipitation estimates measurement, that's where the rain gauge stuff is. But we also talk about radar, including some about Doppler radar. So there are several different places, both in convective weather and precipitation measurement, where you could see some of the Doppler information that you're interested in.
And it looks like Travis has got a question for us here again. Are there any wind mitigation devices to attach to CoCoRaHS rain gauges? There's nothing specifically out there, but people have made their own. They've taken a look at what's usually used, and some have put that around the gauge, but there's nothing on the market that I know of. Do you guys know at this time as an alter shield to go around the gauge?
I don't, but I do want to add something to what you said. A lot of our observers are in communities, they're in yards, suburbs or cities, so there's fences and trees around. In fact, we always are kind of warning you not to have your gauge too close to the tree or building because that could contaminate the rainfall or snowfall. But there's a benefit to having trees at least nearby, not too close, and that is it does disrupt the wind. So those graphs I showed you with how much the gauge could be inaccurate because of wind, that's at its worst when you're in some open field somewhere where there's no disruption to the wind flow. And I don't know where the person who wrote that question lives, but again, a lot of our observers have backyard gauges. So the wind they're getting right in the backyard, especially if the gauge is only like 3 feet off the ground, isn't as bad as if they were in some open field somewhere. So it's probably not as bad as those graphs showed for that set of CoCoRaHS observers.
Okay, Kate is a high school teacher in Minnesota. She teaches earth science. She was wondering, what weather topics have you all found to be of interest to high school students? Have you guys done this?
High school students and middle school as well. Well, I speak, in fact, every year I have a group of middle and high school students that I take along the floodplain. They're very interested in flooding and what that means. But hurricanes and tsunamis actually get attention of a lot of high school and middle school. Now in Minnesota, I'm guessing you don't worry too much about tsunamis. So I would think it's going to be more severe weather up there and floods. I couldn't show everything, but up in Minnesota, Iowa, there was some serious flooding this summer as well, where the CoCoRaHS really played a big role. But for other teachers out there, we have a lesson on med-ed called Hurricane Strike that was geared specifically for the middle school level, and then we have a similar one called Tsunami Strike, again, that was geared specifically for the middle school level.
Yeah, Kate says that winter weather, tornadoes, and floods seem to be the main ones that her students have been interested in over time. Okay, let's take a look. We've got a few more questions coming in here, and Ray would like to know about the skill level criteria you use listed on the different classes. Can you talk a little bit about that?
The skill levels. Let me bring that back. So there are One is what we consider basic information for professionals. So it still is going to be probably technical for a middle or a high school group or the novice, but it's basic information. Two is intermediate. Think of it as more undergraduate level, maybe junior or senior. And then three is the highest level. Again, I'm talking about the little ratings we have here, and that would be graduate level. So that's how we were rating them. It has nothing to do with the length. It has to do with the actual information.
Okay, great. And Matt wants to know, do you have any historical cases available on flash flooding, the storm background impacts information or anything like that on the website?
You know, we don't have a lot of cases, but let me show you what we do have where there's some case information. Classes that we've done is, you know, we focus on the cases, but for our online modules there's not as much of that. But I will show you, we do have we have a module called Flash Flood Processes where we refer to some historic cases. We have one of the earliest ones we did. Let me get down to where it was. Might have even been the next book. Yeah. There's one we have called urban flooding. It could happen in a flash. There it is. And this goes back to, it was published in 2001, but it goes back to a flood that struck Fort Collins, Colorado in 1997. And I do a whole walking tour through it where we talk about what happened in the urban environment. So that was one of our lessons that really is specifically about a case. Interesting that question should come up because that was the flood that actually sparked the idea of having CoCoRaHS. So that's a flood that actually was very important in terms of flash flood and rainfall amounts. But again, a lot of our lessons, if you look like runoff processes and the flash flood processes we have, they refer to cases, but they're not exhaustive studies of any specific case.
Okay, well, thank you folks for typing in your questions today. And we got one more, looks like, here. There's a gentleman here from Palmyra, New York. He wants to know, is there a site that addresses a wind baffle fence type system that can help in snowboard measurements during wind and snow? So is there anything out there that you guys have that talks about that?
No, we don't. I mean, all we address is that wind is a problem and there are these wind screens that official sites like Weather Service and some co-op networks and others will put up these screens to help that problem, but we don't have any specific training on what the different ones are. But I would assume if you Google like wind screening of rain gauges, you might get more information.
Yeah, we noticed many of our observers in Wyoming, they mount their gauges horizontally because the wind blows so much that that's a joke, folks. They don't really do that, but it is pretty windy up there. Well, gentlemen, thank you again for being part of our webinar today and taking time out of your busy day. I really appreciate you sharing this information with us. We'll put more information. We'll have the slides from this broadcast as well as a recorded version up on our webinar probably by tomorrow. And again, thanks for the great presentation, and folks, thanks for your questions.
Thank you, everyone.
I just, before we go, I want you out there to mark your calendars and please join us for our next webinar, and that's coming up in only 2 weeks. So that one will be coming up on Thursday, November 3rd. And Teresa Crimmins of the National Phenology Network, located in Tucson, Arizona, will talk with us about weather, climate, and phenology. And we'll have the sign-up for that available shortly on the website, so don't forget to sign up for that. We'll also send out a reminder for that webinar. And finally, when signing off today, again, please don't forget to take that survey that's going to pop up on your screen. So until the first week in November, this is Henry Regis for the rest of the CoCoRaHS headquarters team saying so long for now and have a great afternoon.